Welcome to this talk about RedisGears. I don't know, has anybody here heard about RedisGears so far? It's quite a new product that we're developing at Redis Labs. So my name is Pieter. I'm produced in Belgium. I used to work for TomTom, the portable navigation devices, and maybe you could see the red wire in my career, but I became a consultant at Neo4j, this graph database, maybe maps, some link there. And then I became a solutions architect at Redis Labs, and now I'm product manager of all the modules at Redis Labs. One of those modules is Redis Graph, which is obviously the red wire that continued into my career. I'll be talking briefly about Redis and Redis Enterprise, and then I'll talk about how we do what we effectively can do with RedisGears. It's effectively, well, we're in an in-memory computing summit. This is our newest addition to the module family. I'll talk about that in a bit more. But we can do stream processing, and we can effectively use it as a real multi-model engine for creating a multi-model database with Redis. So let me just start and ask who knows Redis? Who doesn't? Who does not? So a couple of people. Who has used Redis in production? So, all right. So I don't want to do too much of a marketing pitch, but Stack Overflow does, like, on a yearly basis, they do like a survey to 150,000 engineers, and they ask what is the most loved database. And Redis pops up on top, like the third year in a row, I think, the second to third year in a row. And it's also the least hated database. It's also popping up there in the first place. This is nothing that we created. That's an independent survey that Stack Overflow did. And that's it's quite interesting. Redis is just, it's loved. It's everywhere. Everybody knows it. Everybody has it in their development toolbox and is using it. So apart from that, it's also fast. It's extremely fast. Another metric here is a DB engine ranking. Well, it's a popularity ranking. It's another totally independent one, but you can see that Redis is the first key value store in the list. And why the bloody hell is Microsoft Access right behind us? You've been using it all already. It's everywhere for those who don't know it. So I was going to ask who's using Tinder, but so Twitter is if I would be explaining what Redis does, I'd probably use a Twitter example in a bar to explain it. So your timeline is effectively a list of tweets that you need to read. And every time you scroll down, you'll just ask some Redis instance, give me the next 20 tweets. And you'll see in a bit which data type is specifically suited for that. Snapchat is using it for all their messages. Tinder, we have a geo hash, so we kind of like we have a geo data type. We can effectively do very fast fetching points of interest given a certain point and a radius. GitHub is using it as a repository rather effectively, and Stack Overflow is using it for their entire site caching. And who doesn't know Stack Overflow, right? That's my tagline on my CV. So how do we differentiate? So it's an in-memory database. It's a key value store, and it's a NoSQL database, obviously. But in that specific section, we kind of like have three pillars where we want to differentiate. There's performance, simplicity, and extensibility. I'll dive into performance and extensibility in a bit. For now, just simplicity. So if you would look at the most simple key value store, that would be Memcache. There was a talk before I heard comparing Memcache, by the way, to Redis. So Memcache, the value is always a string. In Redis, the value can be different things. It can be a string, but it can also be a numeric value or a set, sorted set, a list, a hash. And that's quite interesting because you can look at it as memory in a service. Each of those data types come with a number of commands. You could see just as your methods on your basic data types. And you can execute them, but then you can execute them in a distributed database. If that makes sense. So you can, for example, say, I have a list object that lives in my database, and I will say, OK, I want to do an lpop. I want to do a write push into my list. I could use it as a queue suddenly, as a distributed. Everybody following? Right. I could do a test. What could be a method that we could do on two sets? A union, fantastic, or an intersection. So those are the commands. Everything you can think about is present there. Correct. Everybody's following. There are a couple of them that are, well, maybe more interesting. We've got PubSub. PubSub is kind of like a fire and forget. You can publish messages to a certain channel, and you can subscribe to a certain channel. But if you're not subscribed, you will never receive that message. You could use lists to create your own queuing mechanism, if that is a bit more robust. But lately, we added streams. So streams is kind of like the Kafkaesque variant, but it's then it's residing within memory. But you can use it in the same way, right? You can also create a consumer group. So you can either try to consume the stream from any moment in time that you wish to consume it, or you could distribute all your messages to a number of consumers. So speed differentiators, not going to go over the entire list, but yeah, it's written in C. It's served entirely from memory, so the database resides entirely in memory first. That doesn't mean that we don't have any durability options. It's kind of like what we call like a tunable durability. You could use it as a cache, so the data only resides in memory, or you can make it very durable and even have your master and your slave copy both to an append-only file to disk, right? And there's even a sync in between those master and slave, so you never would lose any data. And there's in that spectrum in between, anything we can do. It's single-threaded, so that has some advantages, but also disadvantages. The advantage is that if you have a set of 5 operations or commands, you can execute them in an atomic way, because no other client is going to interfere with it. Single-threaded process. However, if you want to scale it, you will need multiple processes of that, right? And we'll go in a bit and we'll see how Redis Enterprise simplifies that life for you. There might be reasons to scale that, right? There are 2 reasons why you want to shard it, right? Either your data set grows too much or you have a higher throughput. And then there's access to discrete elements within objects, and that's effectively what I touched upon, right? If you have 2 sets, you want to do the intersection. If you would do it in a memcache database, you would have 2 string values that represent the JSON object that represent the set. You would have to fetch them, you would have to deserialize them, and then at client side do that intersection. Now you can just ask your database to do that intersection. It's a very simplistic model. It's very intuitive. That's, I think, why it's loved. The third pillar we have is the extensibility. So what if those data sets or the data types are not sufficient? So now we have an API. You can create your own data types and your own commands against those data types. And while effectively, if you would deploy that module inside Redis, you get all the goodies, right? You get the persistence, you get the high availability, you get the scalability, and you get all the clients that can connect to it, right? So by just implementing that simple data type for you. Can be done in all C or C inherited languages, and it can turn Redis into a true multi-models database. And that's a bit what the story will be about today. So I have a list for you of all the modules that I think are the most interesting to look at. Let me briefly go over them because there's quite some interesting names there. Yeah, it's quite easy to remember the URLs. It's just a name.io. You don't have to. But so Redis Search is effectively everybody knows Lucene and all Lucene-based solutions. I think Elasticsearch. So it's just an inverted index, but then the data resides within memory, and a couple of other things, right? So we will, for example, update our index instantly. So it will have immediate effect if you do a write to your index. But it's written in C, served from memory, and that effectively makes that in the worst case we're like 4 or 5 times faster than Lucene-based solutions. And just off the record, probably it's okay to record it anyway. The way I look at this is I don't think we want to compete that much with Lucene-based solutions. I think they just have a different use case. If you look at if you would like to ingest 7 terabytes of data, of log data, of your monitoring system a day into Redis and into an in-memory database, I would say, why would you do that? Your query pattern is going to be 1 query a day to do root cause analysis because something went down. It's maybe not the best use of your hardware infrastructure. But if you would have a product catalog where you have a couple of thousands of users that are concurrently asking you to do some search within your products, then yes, it's going to be it's going to give you the best user experience. That makes sense? So what we're doing is we're trying to not be the most feature complete in each and one of those. We're trying to be the fastest because it's hosted within Redis, if that makes sense. So there's Redis Bloom, which is a set of probabilistic data structures. So there's a Bloom filter, obviously. There's a Cocoa filter. There's a top K data type. All kind of like probabilistic data types that you could use to limit the amount of memory that you would need. There's a Redis time series. So you could create your own time series with either the streams, because in a stream, your data would be sorted, and you could place your measurements there in some data point in that message. Or you could effectively use a sorted set, and then the sorted set value would point to a hash, and this hash would contain your value. It's quite cumbersome. You can do it yourself. That's the fun part of it, Redis, right? You can also create an inverted index with these sorted sets, right? You can and do some intersection, and then you have an or and an and functionality. But these kind of like add that functionality on top of those basic data types. But Redis time series will come with, for example, with downsampling. So you can have within a key, it will downsample your data into some aggregations, so for long-living data. But it will also add some labels, so you can query, for example, give me all the time series that have the label CPU in EUS 1, for example. Redis JSON is a first step at creating a document database. And I think it's not captured on camera. The first step, so what effectively it does is if you have a large JSON document, we will create a tree out of that. So you can do in an atomic operation, you can say, I want to add this element to my JSON object, and at this spot, I want to add this object to the array. Or I want to increment that counter in that document within a single atomic operation, instead of having to fetch it, deserialize it, serialize again, update, serialize again, and then there might have been some concurrent client that would have updated it. There's Redis AI, which is it's not GA yet, but it's a very interesting module. We used to have Redis ML, which was some very specific data structures that we created for random forest trees, etc. But now we took a different approach. We just went for all the backends, the popular backends like TensorFlow, Onyx, and also PyTorch. And we added a tensor data type. So you can add a tensor. You can write tensor inside Redis. And then you can also call these models. You can add a model into and put it inside Redis. And the idea is twofold, right? So the first thing is, well, model serving in AI tended to be a bit complex, but now you get all the goodies from Redis again. Once again, it's in the mothership of Redis, so you have high availability, you can scale it, etc. The second thing is the data locality. So if you, for example, have a chatbot application, typically takes in two operands. That's your latest message, but also your intermediate state of your conversation. Instead of having to reside it in some separate data store, you can now just run it with the model within Redis. So the input is what is my past history that I've chatted with the chatbot, and what's the latest message. And the output of that model would be the new intermediate state, but also the response to that message, if that makes sense. But now you can reside it within the same solution. And then there is a Redis graph, which is obviously the hot topic, the graph databases. We took a different approach than most graph databases. That is that we used an adjacency matrix approach instead of an adjacency list approach. We're using graph blasts. Anyway, I will stop talking about them now. Each and one of them I can spend half an hour or a couple of hours separate talk on one of them. And we're effectively here to talk about one that is not on the list. So I'll briefly talk about Redis Enterprise. So Redis Labs, effectively as a company, we started as a database as a service provider. I don't want to go over all these items. The idea is that we took our software and we made it available to be deployed on premise. And there's a difference there was some talk about Elasticache I heard before. There's just a difference in incentives, right? So as I said, Redis is single-threaded. If you would, for example, in Elasticache need a database that is 200 gigabytes large, you would get the box with 16 cores, right? But it's single-threaded, so 15 of those cores will be idle. We'll try to, while we as a database as a service provider, our goal was to create a higher profit upon us selling you that database, right? So if we could lower the hardware costs, we could increase our margin. So, but that technology is now available to you to reuse also on premise. So how does it go? In a single cluster, if you would create a database, you would effectively place such a shard, what we call a shard, into, well, it's at least an odd number of nodes. Within a cluster, we would place a single master shard there. This is effectively a slightly modified open source Redis process, as good as the same, effectively. If you want to make it highly available, we'll place a slave counterpart on a different node. If you grow your database, you can create a cluster database. If you want to make it highly available, one more thing to be said. So how does Redis work? How do you know which data resides within which shard? We'll apply a CRC16 and then a modulo operation to determine the slot if you would like to have certain data to reside within the same shard, we can also do some tagging on those keys. And then we'll only do the hashing on those tags. And then if you make your database cluster database highly available, we'll place those shards on different nodes. Now, what is the beauty about this, and this is effectively the core functionality, is that we have a zero latency proxy in each of those nodes. And when you create a database, you will effectively get an endpoint, and that endpoint looks like it's just like the open source database. So your client libraries will just be talking to this endpoint like it's running on your local machine. However, underneath there might be a cluster database, there might be a non-highly available database, there might be database that is durable, certain modules deployed. It looks just like it's a single endpoint. It's not going to be any difference. And that proxy enables us to, for example, to scale your database from 2 to 4 to 8 shards without any downtime, because we can just hold up the request and then update the routing table in our proxy. Any questions so far about... I do want to keep this a bit short because I don't want to make it too much of a vendor talk. So what is the idea that we have with Redis Enterprise, right? So this is how we think that what we call the spaghetti architecture, you want to call it like nowadays a microservices architecture and polyglot persistence. You would place typically your customer data, for example, you would place it in a key value store, but you also want to do, for example, recommendations or friends recommendations, so you might use a graph database. For search, you would have a search product, and there's communication in between all of these. It becomes quite complex because there will be costly communication, but not only that, there's also a higher operational burden and a suboptimal resource usage, because you will have many machines to serve each and one of those technologies. And your people that have to manage, your DevOps people will have to know each and single one of those technologies. So that's a bit where we think we want to scale through, or we want to go to, is kind of like having a single database layer where we'll have Redis, and if you want to have a graph, you will just take a Redis database with a graph module enabled, and you'll have a graph database. And this will simplify your infrastructure. And even on top of that, the communication on top of there, we have the streams and we have the pub-sub notifications. You can also use that as a built-in broker. You don't have to use, once again, another product there. So it's a complete database solution there for you. That's the vision of where we want to go. But there are a couple of things missing. So how will we consume these messages as the built-in message broker, right? So it looked beautiful on the slide, but how will it work in practice? You have some event sourcing or whatever paradigm you're using. You get a message. How will you translate it into the correct operations and into your graph database, for example, or into your search database? Another question could be that Redis is quite simple, but what if you want to do some analytical query on top of your entire data set? There are a couple of ways to do that right now. That is, either you query each shard independently, you gather the results at client side, or you can have we have some Lua scripting, so which who knows Lua? A couple of people. You can use Lua, but you can't go cross shards. So you can, for example, say do the aggregation on a single shard, but then you will still have to combine the results from all those shards. So we need a solution to do some proper, more analytical queries on top of Redis. And then there's a MultiModel and MultiModule. I know those two shouldn't be confused when we're giving a talk. So a database with multiple modules, and that sounds logical for us, but also a multi-model database, what we think is, or where we want to evolve to, is that your data would reside within these hashes. You would, for example, have people and the relationships in between people. And then at a certain moment in time, you say, well, I want to search my people. I want to search those people within that database. You would say, OK, I want to add the Redis search to the mix. And I want to say, well, hey, Redis search, index me these hashes. And then suddenly you have a full text search index. You can do Liebenstein distance, etc., and all those things on top of your search database, on top of your people. Then you say, well, actually, I want to do friend of friends recommendations, who they should meet up with. Well, hey, you add Redis graph, and then you also say, well, these hashes need to translate into these nodes, and these hashes need to translate in these relationships, and then suddenly you get a graph index, secondary index on top of it. That's how we think that by having a single copy in these hashes, you can effectively translate it to the correct transformations. So, but what are we missing to that? Well, we have a single copy, we have these core data sets, we have hashes, modules would even one step ahead, right, would be you ask a graph query to the graph module, and it will say, hey, how do I find this node within my database? And it will say, hey, Redis search, do you have a full text search index for that? So yeah, by accident, I have one here. I supply you the nodes that you need to use to query those spots. That makes sense? That's what meant with inter-module communication. The last thing that we're missing, however, is how do we do these translations? This is component X in between those modules. And that brings me to the, after 20 minutes, to RedisGears. So RedisGears is our newest module that we added. And what is it? It's a serverless engine for multi-model and cluster operations in Redis, supporting both event-driven as batch operations. So it's a bit of a twofold. You can in one way, you can react to certain events within the database, and on a second bucket, you can effectively do operations that cross your entire data set, kind of like a map-reduce style of operations. So what do we have as components underneath? So it's once again, it's written in C. There are 3 components under the hood. There's a gears coordinator. This gears coordinator is going to have knowledge about which keys will reside in which shards. So each query you will execute against with RedisGears should be agnostic if it's a simple single database, single sharded database, if it's a cluster database, if it's a Redis enterprise database, whatever it is, it should be agnostic from that. And the gears coordinator is going to know this piece of your script I need to execute upon this host from this shard. The gears executor is just going to either trigger the certain scripts or going to schedule them. And there is a map-reduce component that is effectively going to do the aggregation and going to wait for each shard to respond with its results. It comes with a C API, obviously, because we want this performance. But we'll also create some integrations on top of that. And today I will show you the Python integration, so you can effectively write some Python scripts on top of your key space. Everybody still following? Right, so the next part will be a couple of demos that I will give with what RedisGears can do. So there might be some bashes, so don't be scared. So the way it works is it's just a pipes and filters that you write within a Python script. The last operation or the last operation component will return you the results, and the first one effectively needs to read some data within Redis. A couple of readers that we have a key reader, we have a stream reader that can connect to a certain stream and just react upon a new message that gets pushed into a stream. We also have a Python reader, so you can create your own triggering. So you can trigger whatever you want to trigger, right? If you would like to trigger it time-based, or you want to trigger it because the weather outside is above a certain temperature, you can effectively trigger something. You've got a number of these operations that should all be basic, right? You've got a map, flatmap, filter, also some aggregations, group by, reduce, sort, limit for each, and a distinct one are the current ones we're supporting, and many more to come. How does it work? There is this reader. It's kind of like our pipes and filter that is shown here. The reader is going to fetch some data, and it's going to pass it to the next operation. In this case, it's a Flatmap. So Flatmap is going to take, for example, a list, and it's going to change the granularity of the pipes that is going to stream through. There are 3 elements into this single list. It's going to pipe through 3 new objects, if that makes sense. And then it's effectively what the consumer or the user of the script is going to use. We can do some filtering. Same there, if a certain document doesn't pass the filter, they will be kept, so only the ones that pass the filter will go there. And aggregation, same, right? We'll keep some counter with the operation, and we'll pass that to the end user. It sounds all quite basic, but this was never present within Redis, so I think this might change some things for people using Redis. So let's go into demo mode. Beautiful. So I will start just a simple container. It has way too many stuff on it, but effectively I'm just using the latest release of RedisGears here in a Docker container. And then I have this fantastic script, which is connect. which is going to give me a Redis CLI so I can connect to that container. So for those who are familiar with Redis, ever seen the Redis CLI? There we are. Redis is very friendly, so if you write something at it, it's always going to write you back. You can ask, well, give me all the keys within the database. It's an empty database. I just started, so there's nothing in there. And you can also ask, hey, Redis, which modules do you have loaded? And there's one, so RG for RedisGears. That is loaded currently. So we will create some keys, right? So we can do a simple set key value. So we'll say set X to Y, for example, right? So we can do that quite easily. So if you would do keys now, we would have one key. If we do type of that key, it would say it's a string. Very simple. We'll do some more. So we'll do an age sets. We'll do an X1, field 1, value 1. And we'll do the same for a second one. And for example, we could do a list too. We could say in a list we'll put some 3 elements. So if we would look now, we'll have 4 keys, 2 hashes, 1 list, and 1 string. Now, what if we want to do, for example, our first gear script? We're going to try to ask, well, give me all the hashes back within a database. There is no way currently to do that without this module within Redis, if you would like to do, for example, operation upon all these hashes. So the command here is RedisGears.py execute. And then your script goes just in between the codes. So it starts off with a gears builder that's going to give you, in this case, well, you could specify more details within this. You could say, well, I want to have a stream reader. I want to have a keys-only reader, different readers, so your own Python implementation. And then you can execute, you can run it. So you could say run it on, with no argument, it's going to run it on the entire key space. So if I execute this, I will get back all my data that is within Redis. Now, what you can do is you can say, okay, I will do a filter because I only want to have the hashes in this case. So we're going to execute a filter command, and in this one you will do a lambda function where we will say execute, and you've seen me doing this, the type command with X, and check that it equals, that it's a hash. So in this case, we should get back live demos. Just X1 and X2 that are our hashes. Fantastic. But it's an empty list or set. I think it's correct. Let me try something. Yeah, you know what I did wrong. Yep. Live demos, isn't that great? So X is an object, as you can see. So what I need to do is I need to specify that I need to get the key to get that back, and then I get my data back, live demos. Right, and you can keep on combining it, right? So I can write another lambda here. Now I'm going to do, let's not do a map, let's do it for each. And I will say, hey, fantastic. Let's do an extra execute, and let's delete this key. I promise you the next time will be smoother. All right. So that's that. If I now do keys, I only have my list and my string back. So that should give you some idea of what RedisGears does. So what are the use cases, right, of this? So there are 2 use cases that I have here right now. So we can connect to a stream. We can consume every message within a stream, and we can do something like event sourcing in this case. We can do a translation from each message in that stream to a certain data module, data type, whatever you would like to do. So stream processing is one. Another one could be the multi-model story that I've been talking about, right? So we have our hashes that are common core data type, and we will be translating on each change or each update within those hashes. We could effectively translate that into, hey, you made an update to a person, you changed the first name, well, we'll update just Redis search. There's no need to change the graph index there. If you would add a relationship to that person, then we would update graph as well. So those scripts can effectively do that translation for you. There's a beautiful demo of this, where we effectively start with a simple Redis database with a couple of hashes in there, and we'll add module by module, and we'll show you how we can effectively start querying in every potential way or in every model that you would like to query. I will point you to that in a bit. So I've got a couple of recipes, so that you don't have to see me typing them. So just the first one is I tried to create 3 of them, right? So this one is just an event triggering, but it's going to react upon each change within a key space. So it's going to say, well, do me a filtering on all the keys that are not all keys, and then add that specific key as add stands for set add to all keys. So you'll have a set with all the keys within your database only, just with this simple script. This one is a MapReduce job. So assume that we have a database with all an IMDb data set with all each movie is represented by a hash, and each hash has a field genres, which is a comma-separated list of the genres for that specific movie, right? So comedy, thriller, whatever, action. And we would like to know how often does a certain genre reside within our database. That's the query we want to ask. So we'll start with, in this case, a key-only reader, as you saw. We'll do an hget for the genres field. We'll say, well, filter out the ones that are not none, and then do a Flatmap by splitting up your string because it was a comma-separated list, and then effectively do a count by, and we would only run it on the movie : star, so only the keys that have a star with movie. So just to limit the space, the hashes there. The last one is a stream processing example. So once again, we start now with a gears builder, but it's a stream reader. This one effectively is going to take each message. A stream is a message that consists out of multiple field value pairs. It's going to take each field value pair and is going to set the key given that field key value, and is going to set it to the value from that message. That makes sense. So if your message there is A1, B2, there will be 2 keys in the end of our database, one with name key A, and the second one with B with the value 1 and 2 correspondingly. If that makes sense, just by passing a single message. That's what this is going to do. So we're going to use a stream reader. We're going to subscribe to the stream called input stream. We're going to register this at the bottom. We'll do a Flatmap because we have multiple of these items. One of these field value pairs is sadly the stream ID, so you want to filter that one out. There's a repartition component I will come to in a second, and that will execute the set command. We'll set that command, that data back within our data set. Now that sounds quite maybe potentially difficult, so let's try to explain this. We have a sharded clustered database with 2 shards, M1 and M2, and our stream resides within the first shard. So RedisGears is going to, there's a message, RedisGears is going to pick this up, and it receives, well, sadly, K1, V1, K2, V2. The first thing it's going to do is the Flatmap is going to say, well, I have 2 separate objects instead of just one, so I'm going to change the granularity. And then there's this repartition component. So I talked about how we calculate which slots, which key resides within which slot within the database with our CRC16 hashing and the modular operation. So you want those keys to reside within the correct shard. So this repartition component is going to do that for you. This is the gears coordinator knows which key should live within which shard. And then effectively, we're going to persist that within the key space. So maybe if that wasn't clear, above the yellow line was the gears memory execution pane, and below was the Redis key space. If that makes sense. All right. One last demo, and then I'm done. But I promise you, it hopefully will be a good demo. So we're going to combine a couple of those modules together. So what we're going to do is we're going to capture my webcam, and we're going to put all these messages within a stream. A stream is going to be the all stream for all images. And we're going to have a gear script. This gear script is going to subscribe to all these messages, consume all these images, and it's going to call a mobile net within Redis AI. It's going to do some classification there. The classification response comes back to RedisGears and goes to say, well, hey, if it contains a cat, then please put that image into a cat stream. That makes sense? Let's see if that demo works out for me. Let's do some screen magic first. So I first want to show you how this demo is built up. You can run it yourself. It's containerized, so it should work just like this. So it has a couple of components. There's the Redis component. This Redis component is going to take our two modules, Redis AI and RedisGears, and load them into a database. It's a bit more complex here. We're still working on simplifying this, but if this effectively is, you have Python, you have all these pip dependencies that you need in your runtime environment, so we need to provide them in some kind of a way, and we need some dependencies to do the resizing of those images. We want to make it simpler that you this component specifically is not GA yet, but that you would, for example, just specify your pip dependencies for a given version, and then per database you would get a virtual environment for your scripts, for your scripts. That's future music. That's kind of like what's happening here. There will be two front-end applications, the web all and the web cats, listening to port 3000 and 3001. One is consuming the streams all, one is consuming the streams cats. And there's the last one, which is the app. And this app is this specific one which contains the gears file. Now, it's not going to go through the entire script, but the gears builder part should be familiar by now. So at the bottom, we're going to take each image because we're going to write the frames into, where is this method? Pass all into.
So that's a method in your Python?
Yes, correct. It's consuming camera.0, colon 0, and we're going to pass it into the all streams first. That's the first thing we're going to do. Then we're going to, well, it's a Docker container. It's not ideally to run mobile net model that is quite computationally expensive. So we're going to do some downsampling of the frames that we're going to use. We're going to execute them, and then we're going to filter the ones that have cats within them and put them add to the stream, which is going to be the stream cats we're going to add them to. So no magic. It's a real live demo. So the only thing I need is a picture of a cat, because okay, I got a picture of a cat ready, because I'm not a cat. So let's go for that. So I've obviously tested it right before this. So I just do Docker compose up, and that's going to create all these containers. Oh, that's fine. I'm happy I know what it is. It's because there's still some Redis running here, and I have this fantastically fine script. Live demos. All right, so the last thing it does is it stops here because this one stops because we uploaded our gear script and everything is now set to go. So we got our browser now. We can go to localhost 3000 and localhost 3001. What I'm not doing yet is capturing my camera. It's not containerized because that felt very tough to containerize, by the way, though it does work on Linux. So what I will do is I will start capturing the images. And then hopefully you should see me there. So on the left, we've got the all streams, and now I have a cat. And this is a live demo. This is not going to work, obviously. This is another one. Come on. Why do I have such a bad? Oh, this is a cute one. No. Live demo doesn't work with me. Nothing there. Ah. Phew. Finally, it works. So yeah, it's more to showcase you what is possible. And we'll turn this off. It's obviously more to showcase you what is possible. It's not that we would recommend you to do cat classification within your distributed database. It's more a fun thing to do. But I think models, for example, that do anomaly detection are a perfect sweet spot use case. We have Redis time series. We can collect all your data there, and we can run that model quite fast. So right. So this is the link to this. So we have our own repo for each module. So if you just go to github.com/RedisGears, this is also where the other modules will be. And if you wanna tweet about this, you can use the hashtag #RedisFoundMyCat. A couple of people tried it, by the way. It's quite funny. So now just a complete picture of all the modules that we have. Just to give you some information, I think Redis time series will go GA this month, Redis AI next month, and RedisGears will be end of this year, early next year. They will support this. Thank you.
It's just RedisGears on C and Python, you don't have for JSON.
We'll just go GA with the Python, not the JVM yet. That will be for next year.
Okay.
It's a bit more of a complex module than the other ones because all the modules were self-contained. If you had a time series, you just write your data type in C and that's it. Redis AI is a bit more complex because suddenly you have TensorFlow dependencies.
And that stream is going to process only in single flow each of those items. When you have a stream with a collection of whatever, it's going to be one at a time with a single thread.
Right. So at this moment in time, it will be single-threaded, but it could be an option for us to parallelize that, right? To create a thread pool and do that in a parallel manner. Yeah, sorry.
Compiling the Python to C.
So it's an interpreter. So yeah. So it is Python code that is calling C methods underneath. So it's not ideal, right? But so it's more to have you play around with it, and then use the C library effectively to make your most optimized implementation.
And you could eventually decipher something to C.
Yes, yes. I think that might be more suited languages later on. We still have to figure it out. There might be Rust that is ideally suited for this to do so.
Were the gears operators similar or different from Spark?
I don't know Spark that well, so I don't know if I'm very well suited to answer that question. So the gears executors, if you do a run command, and it will keep a queue of, if it's just a run command that's going to do some MapReduce job, it's going to queue that up for you. So I'm going to do that immediately. The triggering of the key spaces will happen at the moment they effectively happen, right? So it's a synchronous call to gears that is going to execute that script. Synchronous? It's asynchronous. Sorry, it's asynchronous. So it's not going to block your command. If you do a write to a certain key, it's not going to block that for you. It's going to do it asynchronously for you. But how it's different from Spark, I don't.
I didn't mean the implementation. I meant the set of operators.
The set of operators. I think it's. Yeah, right. I get your question now. I think we should get quite close, right, eventually. So once again, I don't think we want to. I said with each of these modules, we don't want to be the most feature complete one. We want to be the fastest one. So if we will open up the API. So there will be an API where you can implement your own operation if it's not present, right? So you could add that yourself. That make sense?
Yes. So you believe the implementation of Spark versus RedisGears? RedisGears would be faster in most cases?
No, with the Python code, yeah. But with the C code, yes.
What is the effect of the RDS in Spark versus replication in Redis?
I'm sorry, I didn't get your question.
The resilient distributed data set. RDD, sorry. That's what Spark has, resilient distributed data sets.
Right.
So how is that going to affect performance relative to doing replication in Redis?
I don't know the answer to that question, sorry. I don't know Spark well enough to answer that. It's a very good question. I would be happy to take your details and answer that later on, effectively. Sorry.
In general, it's meant to be a Spark killer, is that right? Or maybe that's the wrong term, but you know what I mean. It's meant to compete directly with Spark and have people use Redis.
I don't think so. No. We have a Spark Redis integration component, so you can still take all your data into and migrate it to Redis, and we're supporting that one too. I think it's more for use cases where, for example, you have some fraud stream of data that is coming in. You want to do instant classification of that and also write that back into another stream. And you can now do that within the same host. You don't have to go to another host. So Gears can consume that message, call Redis AI, say, hey, you need to put this object in your time series data for long-term historical data, and just also this is the response, by the way. So I think it's more it's just twofold, right? There is the map-reduce type of operations, but there's mainly the event processing component there.
What was not completely clear for me is this Python code now running in the same single thread as the Redis server itself?
Yeah. And no, it's a separate thread.
It's a
Separate thread.
Yeah. So you're not able to slow down all the other operations from your Python script?
So you're not able to?
Yeah, slow down all the other ongoing operations.
No, you won't, right? Yeah, no, so no, you won't. There is, however, if you need to fetch data from other shards, that will go into the main thread, because we'll have to say, hey, give me, it's like in a map reduce kind of operation, we will ask that data. So that will, but it's optimized not to do a long, bulky thread of operations, right? So it's going to do that in small chunks and interleave that, so you can still use it in an operational way. Hard questions. We're still pretty new to this module, I have to say. It's the newest member to our family, but I think it's really exciting for those who use Redis. They might suddenly see, okay, yeah, I have so many problems or things that I wanted to solve in a way. This is going to help me resolve those.
Maybe one question. I showed an example where you were working on all the keys on your database. Let's suppose some of the keys are on different nodes.
Yep.
Would it do the computation on each node for the data it has, or will it
Yes.
do all the data on one node?
It will. Yes, it's a good question. So it will try to optimize. It depends on which operation you're using and in which step it's going to be in your pipes and filters. But if it can, it doesn't need all the raw data. It's going to aggregate that. So yeah, in an average, that's quite easy. But it depends on which aggregation you have. Is going to do that within the same hosts and only respond to results back.
One more, is it also like compatible with like the time series modules?
Yes. So good question, right? So I'm loving my job. It's fantastic. Because what we're going to do is each module is going to register its own module API to RedisGears. So the moment you have RedisGears loaded as a module, and you also load Redis AI, it's going to say, hey, RedisGears, these are the methods you can call. Obviously, you can't check when you write your script if these methods will be available. So there needs to be some version detection that we will have to make sure that is the case. But at this moment, time series is not GA yet, but in the next version, the 1.2, 1.1, we'll publish that API within RedisGears, and then you could call it directly. And that will open up, let's say that time series is, will go GA with, with, let's say, 8 out of 10 or 9 out of 10 queries you could do. Not all of them, all type of aggregations will be possible. But once we open that API into RedisGears, you can do whatever you want to do, right? You can just call all your time series keys within Redis and do the aggregation you want to do and respond them in such a way that you want to do them. So that will allow us to, if we have edge cases that we can't answer natively with a native query language for Redis time series, you can do it with Gears.
You mentioned that.
Last question, yeah.
Last question. You mentioned that Redis cache is, Redis search is kind of Elasticsearch, right? So in our production, we use Elasticsearch and Logstash for log aggregation. So is there any plan for your product side to work on the log aggregations and indexing them?
So creating an elk stack kind of like project.
A log stash and Elasticsearch?
Yeah. So the elk stack, right? That's what you're asking, right?
Yeah.
So no, we see that question quite often, and we don't have it planned right now. It's something that we've heard before. But as I said, I don't think it's a perfect use case for putting all your log data in an in-memory database. Maybe that sequence of, if I would have 7 terabytes of logs that I'm generating every day, I put them in an in-memory database, and then my query pattern would be a root cause analysis to do kind of like, okay, something went wrong, can I find this log? Do you need sub-millisecond latency to get that answer back I'm just opening the question here, right? So I think it's more you have a product catalog, or you have some high throughput parallel querying where you want to give the most smooth experience onto your search.
I'm thinking on the other line, like when the logs are coming to your cache, you can use complex event processing or some kind of windowing thing, and look at the different kind of exceptions or errors and kind of generate alerts
and keep those specifically. Right, that could be a good use case to keep only the to be inspectable ones into Redis search. Right, that makes sense. Most of Redis adapters are community driven, right? So I'm sure that if there's a need, somebody will eventually create it, if not us who create it. Thank you.